We're going to now look at standard normal probabilities, also called a normal distribution. We talked about this last time. Our standardized score, or our z-score, is written as z equals x, whatever our x value is, minus the mean, divided by the standard deviation. A normal distribution, mu is the center, and the spread is the standard deviation. So if we have this histogram, a normal distribution is going to describe this histogram in terms of a curve. So that's what our normal distribution looks like. If you don't have a graphing calculator, you want to make sure you have Desmos. You need a calculator that does z-scores in order to complete this lesson. If you have a graphing calculator like a TI-84 or a TI-83, then these are the instructions. What you're going to be doing is you're going to be using your calculator function. So you're going to take your x value, you're going to turn it into a z value, which we've already done. And then what we're going to do is we're going to find the area under the curve. How we do that is using the calculator. We go to the distribution, then we move over to normal CDF. And how normal CDF works is we put our least value, then our greatest value. So if we're looking at example 1, what you're going to do is you're going to use your normal CDF, and you're going to put the number 1.17, and then you're going to put comma, and then you're going to pick a large number. Now, a large number could be 100, it could be 1,000, it could be 1,000,000. I just pick 100. That's just an easy one for me to remember. You put that in your calculator, and you get the probability or the area of 0.121. Now, looking at letter B, we're going to do the same thing. We're going to go over to normal CDF. We're going to put our least value, which in this case is going to be negative 100. Notice that it's less than, so it's all the values that are less than. So that's going to go to negative infinity. All the values that are greater than are going to go to positive infinity. And then we put the number, which is negative 1.37. Then we hit enter, and it gives us our answer of 0.085. And for letter C, what we're going to do is the same thing. We're going to do normal CDF, and we put our least value, which in this case is negative 3, then our greatest value, which is 1.5. We hit enter, and it gives us the answer of 0.932. Now, let's skip example 2 and go to example 3. This is where the 3 steps come in handy. What we have is we have an x value. So the x value is greater than 60. So if it's greater than 60, we're going to go x is greater than 60. We're going to change that into a z value. So we're going to go 60 minus our mean, which is 40, divided by our standard deviation, which is 10. What we're going to do is we're going to subtract it, and what we get is 2. So we're going to put it in our calculator. We're going to go normal CDF. We're going to go 2 comma a large number. And then that right there is going to give us a probability or an area of 0.023. Now in this next case, it's less than 30. So that means that the z value is also less than. So it's going to be 30 minus 40. Remember, it's always the mean, divided by the standard deviation, which is 10. So that right there is going to give you negative 1. So we're going to plug it into our calculator, normal CDF. We're going to put our least value, which is negative 100. Our greatest value is negative 1. And that gives us a probability of 0.159. Now, looking at letter C, this time it's in between 20 and 60. So if it's in between 20 and 60, that means that our z value is going to be in between also. 20, which is our x value, minus the mean, divided by the standard deviation. We're going to do the same thing. We're going to take 60 minus the mean divided by the standard deviation. That right there is going to give us two values. It's going to give us -1 and it's going to give us 0.5. Sorry. It's going to give us -2 and it's going to give us 2. So we're going to use the normal CDF and -2, 2. And that right there gives us a probability of 0.95